for another video, and for today's video is all about Chapter 5, Ethernet. I'm going to answer all the activities included in this chapter. So the first activity is about MAC and LLC sublayers. First, the instruction is descriptions of the MAC and LLC sublayers are provided in the table. Click in the MAC or LLC fields to match the descriptions to the correct sublayer. So the first statement is controls the network interface card through software drivers. The answer is LLC. The next works with the upper layers to add application information for delivery of data to higher level protocols. It is also LLC. Then works with hardware to support bandwidth requirements and checks errors in the bits sent and received. So the answer is MAC. Then controls access to the media through signaling and physical media standards requirements. It is MAC. So let's check. So the answers are correct, but it says that it is incorrect. So let's try again to guess what is the answer of these two. So MAC, then so the other one is incorrect, so let's change it into LLC. So all the answers are correct. Next, let's move on to another activity. Next activity is about identifying Ethernet frame field names. So the part 1 is the descriptions of these given words. So instruction, drag the 802.3 Ethernet frame field name to its description. Let's start. First, use a pad to increase this frame field to at least 64 bytes. It is 802.2 header and data. Then, describes which higher layer protocol has been used. It is type. Then, the frame's originating NIC or interface MAC address. It is the source address. Then assist the host in determining if the frame received is addressed to it. It is destination address. Notifies destination to get ready for a new frame. It is preamble. Then synchronizes sending and receiving devices from frame delivery. It is start of frame delimiter. Then detects errors in an Ethernet frame. Frame check sequence. Let's check. So the answers are correct. So in 802.2 header and data says that the pad increased this frame field to at least 64 bytes. Then in type describes which higher layer protocol has been used. Then source address is the frame's originating NIC or Internet Media Access Control address. Destination address assists a host in determining if the frame received is addressed to it. Preamble notifies destination to get ready for a new frame. Start of frame delimiter synchronizes sending and receiving devices from frame delivery. Last is frame check sequence detects errors in the Ethernet frame. Next, part 2 is identify Ethernet frame field name. Instructions. Drag the Ethernet frame field name to its correct location on the diagram. So, in this diagram, it says the bytes given to all the given answers that you need to drag. So, first 7 bytes, next 1 byte, 6 bytes, then 6 bytes again, 2 bytes, 46 to 1500 bytes, and last is 4 bytes. So the answer in 7 bytes is preamble. And in 1 byte is start of frame delimiter. Then in 6 bytes is the destination address. And in 6 bytes also is the source address. Then next is length for 2 bytes, and then 802.2 header and data for 46 to 1500 bytes, and last frame check sequence for 4 bytes. Let's check. So all are correct. Let's move on to another activity. The next activity is switch it. This activity is also I also do this in the last activities, so I'm just going to answer it again because it is included in chapter 5. So let's start. The instruction: determine how the switch forwards a frame based on the source MAC and destination MAC addresses and information in the switch MAC table. Answer the questions below using the information provided. So as you see in the figure, this is the Cisco switch. Then this is the host, the frame, then the ingress port. then this is the hub. Then this is the frame that includes preamble, destination MAC, source MAC address, length type, encapsulated data, and end of frame. Then in MAC table, it includes FA1, FA2 to FA12. Then as you see in frame, destination MAC address is FF, which is included in broadcast frame. And then source MAC address is OD that connected to FA7. As you see that the frame is in the host OD. Then in MAC table, FA7 is OD. It is just only one given, so we need to answer question 1. Where will the switch forward the frame? Then it will be FA1, FA3, FA5, and FA9, because FA7 is already given because it is the source MAC address and this. Then in question 2, when the switch forwards the frame, which statements are true? First, switch adds the source MAC address to the MAC table Frame is a broadcast frame and will be forwarded to all ports. Frame is a unicast frame and will be sent to a specific port only. Frame is a unicast frame and will be flooded to all ports. And last, frame is a unicast frame but it will be dropped at the switch. The answer is frame is a broadcast frame and will be forwarded to all ports, because a broadcast frame included FF, and then as you see in question 1, the broadcast frame are forwarded to all ports, the FA1, FA3, FA5, and FA9, wherein in the figure that shows here on the screen is that FA1 is given FA3, FA5, and FA9, but the FA7 is already given. This is the source MAC address. So let's check if it is correct. So this is correct. Next activity is about frame forwarding methods. So the instruction is descriptions of switch frame forwarding methods are provided in the table. Click in the star and forward or cut through fields to match the methods to the descriptions. So we just need to choose store and forward or cut through. Description: buffers frames until the full frame has been received by the switch. It is store and forward. Then checks the frame for errors before releasing it out of its switch ports if the full frame was not received. The switch discards it. It is also store and forward. No error checking on frames is performed by the switch before releasing the frame out of its ports. It is cut through. Then a great method to use to conserve bandwidth on your network is store and forward. And last, the Destination Network Interface Card or NIC discards any incomplete frames using this frame forwarding method. This is cut through. Let's check. So my answers are correct. So again, we need to check in this unknown question. So let's guess cut through. So it is correct. Let's move on to another activity. Activity is about frame forwarding methods. And instructions: read the scenario. Based on the topology shown, identify how the frames will be processed by dragging your answers to the appropriate fields provided in the table. All answers will not be used. First, this cabling used in this topology will be straight through. To find where PC2 is located, PC1 will send out a broadcast. PC2 will respond back to PC1 by sending back a unicast message. If PC2 receives only half of the data in the frame, it will discard it. Then if PC2 receives many damaged frames on port 3, S1 likely will change back to store and forward switching. Let's check. So it is correct. So that's all for today's video. So thank you for watching. Bye.